Good afternoon. I am Indrakumar, Assistant Professor, Marine Engineering Department. Today we are going to see the topic pumps in the marine field. Okay. First, we are going to discuss about the what is pump, what are the uses and applications, what are the types, what are the different losses inherent in the pump. First, pump. Pump is a machine which convert mechanical energy into potential energy, kinetic energy, thermal energy, and pressure energy of the fluid, and is used to raise the liquid from lower level to higher level. A pumping system on a ship will consist of suction piping, a pump, and discharge piping. The pump serves as a mean of transporting fluid. Marine pumps can be used for cooling water, fuel oil transfer, lube oil transfer, FO and FS cargo pumping, cargo stripping, hydrophore tank unit, freshwater generator, oil water generator, incinerator, sewage treatment unit, ballast circulating, general service firefighting, boiler feed water, freshwater and sanitary water sludge and bills and so on. Next, we are going to see uses of pumps. The pumps are widely used on board ships for the following purposes. The first most purpose, the domestic freshwater supply to bathroom, wash basin, galley, means a kitchen, etc. Fireman sanitary supply of seawater, machinery cooling by seawater, freshwater, pumping out bilge and flooded compartments, supply of fluid for operation of steering gear, stabilizer and hydraulic machinery, circulation of brine in air conditioning plants. Next, we are going to discuss about the types or classification of pump. The pumping action can be achieved by various ways depending upon the type of pump used. The pumps are broadly classified into two categories. The first one is positive displacement pump and the second thing is dynamic pressure pump. It is otherwise known as rotodynamic pump. The positive displacement pump. The positive displacement pump is defined as the pump which creates suction by increasing the volume by mechanical vibration at the suction side and achieve the discharge by mechanically reducing the volume of the chamber in which the fluid is trapped. The positive displacement means that once the fluid is trapped in the chamber by suction has no way to go back to the suction. It has to be discharged, which means it is absolute necessary to operate the positive displacement pump, which is discharge valve open. All the displacement pumps are self-priming pump. The pump like gear pump, reciprocating pump, screw pump are included in the positive displacement pump. That means the example of positive displacement pumps are gear pumps, reciprocating pumps and screw pumps. Next, this is a line diagram of single acting reciprocating pump. What are the construction? It has a suction pipe and suction valve on the other side, delivery pipe and delivery valve, cylinder, piston. The cylinder is known as chamber. Then piston rod, connecting rod and rod. Okay. The piston actually in the initial state the suction valve is closed. Both suction valve and delivery valve is closed, remain closed. The piston is at the TDC. That means on the other hand, the crank is at the 0 degree. When the crank rotates from 0 degree to 180 degree, the piston starts from TDC to PDC. Once the crank reaches the 180 degree, the piston moves from TDC to PDC. At the same time, due to the pressure difference, the suction valve automatically open. The water from the sump level trapped into the chamber. that is cylinder. Once the crank rotated from 190 degree to 360 degree, the piston automatically moves from DDC to DDC gradually. At the same time, the delivery valve open, the suction valve remain closed. Due to that, the water from the chamber cylinder is trapped to the delivery pipe through the delivery valve. This is the overall construction of the single acting reciprocating pump. The reciprocating pump is a type of positive displacement pump which includes the piston pump, plunger pump and diaphragm pump. If the level of the liquid to be pumped is below the center line, then the vacuum is created into the pump. Due to this, the water is automatically shut. Then, what are the advantages? It is an actually self-priming pump having high head. What are the disadvantages? Means it is the construction of the pump is complex and a relief valve is required to release the excessive pressure. This is one disadvantages of the pump. Next, the gear pump. The gear pump is of very common design. It is used for pumping many types of fluid and gas and is able to delivering at very high pressure. This makes it suitable for hydraulic supply. The tooth profile is similar invalid gear tooth for the liquid pumps. For gas pumps, special profiling with very fine tolerances used. Uses of the pump is, that means application of the pump is lube oil, boiler fuel oil pump and main engine driven lube oil pump and many more. This is a schematic diagram of the gear pump. Tooth profile. Gear tooth profile is used. Both are rotated in opposite direction. The left side is the inward section, the right side is the outer section. Due to the rotation, the gap between the two gear tooth is filled by the oil. Due to the rotation, the movement of the pressure will be varied at the discharge time. Okay. Then these pumps are seen in many applications have a higher capacity than the double the load type. Fluid enters the pump and screwed by the idler shaft along the outer edge to the discharge port. Axial thrust of the idlers is absorbed by the integral thrust collar of the driven shaft. The axial thrust of the driven shaft is absorbed by the thrust bearing. The scroll sits in the replaceable insert which is sealed to the outer casing by O-rings. Next, the screw pump. This is a schematic diagram of a screw pump. The dynamic pressure pump, that means a rotodynamic pump, are pumps in which energy is continuously added to the fluid within a pump. This results in increase the fluid velocity. At the later stage, this velocity may be reduced to increase the pressure. This results in increasing the fluid velocity. At the later stage, this velocity may be reduced to the increase the pressure. This pump may require priming, and for this purpose, reciprocating pump may be used. Next, the centrifugal pump. The centrifugal pump is a machine that uses rotation to impart a velocity to the fluid. It then converts that velocity into the flow. The definition tells us two things about the centrifugal pump. First one is the energy is imparted to the liquid in form of velocity by the impeller. The second thing is energy is getting converted into flow by the casing of centrifugal pump. This pump is an impeller and casing work in union to create a steady pressurized flow. The application is general service, firefighting, main pump, nozzle cleaning, hydrospore supply. This is an line diagram of centrifugal pump. Overall, the construction of the pipe is the suction pipe, then impeller, a casing, eye of the pump, delivery pump, delivery pipe and delivery valve. In this case, we have a two head, suction head and delivery head. What is suction head? The height between the sump and the center of the impeller. This is known as suction head. And the one more head is employed, that is delivery head. The distance, vertical height between the eye of the impeller pump to the delivery pipe. This is known as delivery head. The sum of the suction head and delivery head is known as total head. We have used the formula for the problem solving purposes. Here, the foot strainer or foot valve is used to drain the dust particle or dirt particle. From the sump, the water flows from the pipe to the eye of the pump or impeller. Due to the force supply, the centrifugal forces are due to the centrifugal force, the water is splashed to the impeller section through the casing. Through the casing, the water flows to the delivery pipe through the delivery valve. So the water is led to the section of the rotating impeller. The water gains energy by the centrifugal action of the pump and is discharged to the olive outlet case, so that it is known as centrifugal pump. The volute is created by increasing the area of the outlet port and its greatest at outlet from the pump. By this design, the kinetic energy of the water is converted into the pressure energy. Sealing is provided by a mechanical seal or by packed gland. For cooling water is supplied from the discharge side of the pump. For the later cooling is provided by elements of straight leakage. Lubrication is by a grease-filled manual lubricator. The kinetic energy of the fluid flowing through the impeller is converted to the pressure energy by the shape of the olive casing. For high pressure pumps such as the boiler feed pump, a diffuser ring is fitted into the casing, which converts the greater portion of the pressure energy, allowing greater pressure at the generator. A scroll type inducer may be fitted to the inlet, which improves the efficiency of the unit and allows the pump to operate with the low suction pressures. The volute casing centrifugal pump is a casing of centrifugal pump in which the cross section of the casing increases gradually as the fluid moves towards the discharge. This increase in cross section results in decrease of the fluid velocity, that is decrease in kinetic energy and convert into the pressure energy. The shaft is eccentric in involute centrifugal pump. Next, we have to discuss about the two types of casing, volute casing, vortex casing. This is a line diagram of an volute casing. We have a eye, impeller, rotating impeller and shaft and the discharge pipe, in which the area may be gradually increased from center to the discharge. The vortex casing centrifugal pump. In this pump, there is a circular chamber between the impeller and the casing. The liquid first enters into the circular chamber vortex, then volute casing. The eddy loss is considerably reduced by the employing vortex casing, and thereby the efficiency of the conversion from kinetic energy into the pressure energy is increased as compared with the volute casing. Next, this is a vortex casing. Here, from the diagram itself, we know the cross section or circular section will be from the center to the delivery pipe is equal, similar. So it is known as vortex casing. Then we are going to discuss about the care and maintenance of the pump. The pump is a type of machinery which is used in larger number on boards, both on deck side and engine side. Every seafarer working on ship must be aware of the basic problems associated with the pumps and practical ways to troubleshoot whenever need arise. While handling pumps on board ship, you do not need to be an expert. All you need to know is how to identify some basic signs and preventive actions which are to be taken whenever required. Mentioned below are some of the main problems that are associated with the pumps on board ship. Main problems found in pumps are: first one is delivery failure. The pump is not able to deliver at the required pressure. Pressure is the most important criteria while designing the pump is important. First point, check the following in order to tackle this issue. Ensure that the pump is primed properly. Check if the pump is moving with a sufficient speed. Check for oil air leakage. Ensure that the impeller, or gear, or screw, or other liquid driving mechanism is not broken or damaged. The pump shaft should move in the right direction. Check that the suction lift is not more than the required. Ensure the temperature of the liquid is not below the pump able limit of the pump. The second thing is priming failure. The priming is required in order to start the most of the pumps. If the pump is not able to prime properly, check the following: a leakage in pump joints, leakage in gland joints, air leakage, faulty priming, and drive. The third point, inability to build pressure. If the pump is not able to build enough pressure in order to ensure smooth flow of liquid, then check if the priming is done properly, the air cogs are not open, internal moving parts such as impeller, screw, etc. are not damaged, bearings are not worn out or damaged, the pump is running at the right speed, there are no other mechanical defects in the pump. Check for cavitation in the casing of the pump. The fourth one is excessive vibration. Sometimes the pump vibrates a lot of making a loud noise. If there is a lot of vibration in the pump, check the following things. First, ensure there is a no loss foundation. The alignment of the pump is proper. There is a no impeller imbalance or erosion. There are no mechanical faults. The distance pieces between the pump shaft, motor shaft is of correct length and is not worn out. The rubber bush bees connecting to the motor and pump shaft is not worn out. There are no worn bearings or venture. Ensure there is a no loose foundation. The alignment of the pump is proper. There is no impeller imbalance or erosion. There are no mechanical faults. The distance piece between the pump shaft and motor shaft is of correct length and is not worn out. The rubber bush piece connecting the motor and pump shaft is not worn out. There are no worn bearings or venture. This is a point or comes under the excessive vibration. Sometimes the pumps vibrates a lot, making a loud noise. There is a lot of vibration in the pump. The following points to be checked. Next, the fifth one is the reduced capacity. The several times due to continuous running, the capacity of the pump reduces drastically. If the capacity of the pump has been reduced or there is an insufficient capacity to check the pump is running at the proper speed, there is a no air leakage, there is a no obstruction in the suction pipe. Ensure that the suction lift and temperature are not too high because the temperature will be we have to maintain the temperature, moderate temperature. The total dynamic head is not larger than the rated. The dynamic head almost at the required level. The setting of the pump relief valve is not below the required value. We have to set the value of the valve relief valve is maintained. Below that, it will not be set. These are the reduced capacity of the losses. The pump is running at the proper speed. We have to run the pump at the proper speed. That there is no air leakage in the pipe. The third point is there is a no obstruction, any struggle in the suction pipe. Ensure that the suction lift and the temperature not at high level. Dynamic, total dynamic is not larger than the required. Then the setting of the pump relief valve is not at below required level. Then motor overload. This is a very common pump problem found on the onboard ships. If the pump motor overloads, then immediately we have to check the following point. The speed of the pump is not high. The quantity of the liquid pumped is not too much. The viscosity of the liquid is up to the marked level. Valves in the line are in closed position. Problems are obstruction in the rotary parts of the pump. This is the 6 points where comes under the motor overload. There is a very common pump problems found in onboard ship. If the pump motors overloads, the speed of the pump is not too high. The quantity of the liquid pumped into not too much. The viscosity of the liquid is up to the mark level. Valves in the lines are in the closed position. Problem or obstruction in the rotary parts of the pump. Then the liquid, losses of liquid. If the pump loses liquid after starting or during the running, we have to check first. Check if the suction lift is as required. Then check for any kind of leakage in the suction line. Check the temperature of the liquid. Ensure the relief valve of the pump is set at the right value to avoid loss of liquid to overflow line. These are the points comes under the losses of liquid. If the pump loses liquid after starting or during running, we have to check the point. This is the almost important point. Then we have to set a suction lift. If it is below the certain level, the severe damages will be occurred in the pipe. Then the third thing is check for any kind of leakages in the suction line. Then the temperature of the fluid is at the medium level. If it is too high, the pipe may get damaged. Ensure the relief valve of the pump is set at the right value to avoid loss of the liquid to overflow the line. Then what are the final marine pumps can be used for the various purposes. We have to use the pump in the cooling water purposes. This is an almost important and most point. Cooling water purpose is the most purpose point. Then fuel oil transfer. We have to transfer the fuel oil from tank to engine. During the transfer of the oil, we may use so many pumps. Then similar to the oil fuel transfer, we have to use the lube oil transfer also. Lube oil means lubricating oil transfer. Through the lubricating oil transfer is the pump is also used. Then the fourth point is the fuel oil and fuel with cargo pumping is an almost important point. In addition to that point, we have a cargo stripping point, then hydro for tank unit, freshwater generator. The freshwater generator also we have used the pump. Then oil water separator. We have to separate the oil from the water. During the places also they have used pump. Then incinerator. Then the sewage treatment unit, ballast, then and circulating pumps. General services and firefighting also they are used pump. Then boiler, feed water, and fresh water generator usage, and sanitary water and sludge and bills and so on. These are the most and important usage of the pumps in the marine field. According to the point, we have to use multi-purposes. First one is domestic fresh water supply to the bathroom, galley, etc. and firemen and sanitary supply of seawater, and machinery cooling by seawater and fresh water, pumping out bilge and flooded compartment, supply of fluid for the operations of steering gears, stabilizer and hydraulic machineries, circulation of brake and air conditioner. These are all the widely used on port ship for the purposes of the pump.